Hello everyone. Now I am going to discuss the radiographic testing interview questions which are very frequently asked. The very first question is, what is radiographic testing? To answer this, you can say that radiographic testing is a NDT method that examines the volume of a specimen. It uses X-rays and gamma rays to produce a radiograph of a specimen showing any changes in thickness, defects, and assembly details to ensure optimum quality in your operation. It is based on the principle that the radiation is absorbed and scattered as it passes through an object. If there are variations in thickness or density due to defects in an object, it means more or less radiation passes through and affect the film exposure. Let us move on to our next question. What is the difference between conventional and digital radiographic testing? Conventional radiography uses a sensitive film which reacts to the emitted radiation to capture an image of the part being inspected. Whereas digital radiographic testing uses a digital detector to display the radiographic images on a computer screen almost instantaneously. Images produced with conventional RT have limited dynamic range, but digital radiography allows for many exposures to build up a high contrast image. Our digital radiograph can be easily copied, emailed, and enhanced without degradation. Moreover, they do not get damaged over time. Now let us move and go to our next question. So the next question is, what is half-life of a radioactive isotope? You can say that the half-life of a radioisotope is the duration in which its activity reduces to one half of its initial value. You can see that its initial amount is 100% and after first half-life it's only remain 50% and after second half-life it is 25%. You can also give an example such as that of cobalt 60. The radioactive isotope cobalt 60 has a half-life of 5.26 years. This means that after this interval, a sample originally containing 8 gram of cobalt 60 would contain only 4 gram of cobalt 60 and would emit only half as much radiation. Next question is, what is gamma radiation? A gamma ray, also known as gamma radiation, is a penetrating form of electromagnetic radiation which emitted from the radioactive decay of atomic nuclei. It consists of the shortest wavelength electromagnetic waves, typically shorter than those of X-rays. In a radioisotope, if after the emission of an alpha or beta radiation, the nucleus still has some extra energy, then gamma radiation is emitted. Gamma radiation is highly penetrating and it is like X-rays in its properties. Moving on to our next question, which is how X-rays are generated for industrial purpose. To answer this, you can say that X-rays are generated when free electrons give up some of their energy when they interact with the orbital electron or nucleus of an atom. The energy given up by the electron during this interaction appears as electromagnetic radiation known as X-rays. X-rays are commonly produced in X-ray tubes by accelerating electrons through a potential difference and directing them onto a target material, generally tungsten. So, in order to generate X-rays, we must have three things. First, we need to have a source of electrons, then a means of accelerating these electrons at high speed, and a target material to receive the impact of the electrons and interact with them. Our next question is, what does one meant by half value thickness and tenth value thickness? A material half value layer or half value thickness is the thickness of the material at which the intensity of the radiation entering is reduced by one half. Whereas tenth value layer is defined as the thickness of a shield or an absorber that reduces the radiation level by a factor of 1/10 of the initial level. So, the thickness of any given material where 50% of the incident energy has been attenuated, is known as its half value layer, and thickness where only 10% of energy remains is called 10th value layer. Moving on to our next question, which is what is single wall exposure technique in radiographic exposure? You can answer that in this technique, the radiation source is placed opposite of the film, keeping the object between the film and the source. This is the simplest arrangement and the most practical setup. In the single wall radiographic testing technique, the radiation passes through only one wall of the weld or material, which is viewed for acceptance on the radiograph. For example, if this arrangement is used in a pipe, the film is placed in the pipe close to the weld and the source is outside the pipe at a distance from the pipe to make a good exposure. Next is what is panoramic exposure technique used in radiographic testing? You can answer that this technique is used for cylindrical objects such as pipe of relatively large diameter, generally greater than 90 mm. In this technique, the films are placed on the outer surface close to the weld and a source is placed in the pipe so that it sits in the center of the pipe. This technique produces a film that has radiation penetrate through a single wall of the material, producing a simple image of the weld on the film. This method is used to detect welding joints in pipes which are more than 10 inches in diameter, where it is possible to have a complete circular image for the circumference of the pipe in the region of welding. It is done by putting the source of X-ray or gamma ray in the center of the pipe from inside where two pipes join in the welding part. Moving on to our next question, which is how do we calculate minimum source to object distance? To calculate this, first we need to find geometrical unsharpness for a particular exposure. Its value is taken from ASME section 5 article 2, which gives us maximum allowed unsharpness. Then we use this given formula to calculate our source to object distance. So, knowing the source size, object to film distance, and geometrical unsharpness from the table, the unknown minimum source to object distance can be found. Now, our very last question is that if you were faced with too much back scattered radiation or undercut during a radiographic test, what would you do to remedy this? You can say that to control backscatter, I would back the cassette with a sheet of lead. The sheet should be at least a hundredth of an inch thick, and to control undercut, I would use a sheet of lead cut to fit or a liquid absorber to mask the hollow areas from excessive radiation. Undercut happens when hollow areas in the tested object causes abrupt darkening of the radiograph. We want to control this because it can lead to blurring at the point of transition between solid and hollow areas. Alright, this was all about interview questions related to radiographic testing. Hope you enjoyed the session.